Hello everyone. This problem has been asked in GATE 2013 and it is of 1 mark. GATE 2013 and it has weightage of 1 mark. And this problem is from the analog and digital circuit subject. So let us see the what the problem says. So in this problem it is given the question is that in the feedback network shown below, if the feedback factor K is increased, then the input impedance increases and output impedance decreases, and B option is input impedance increases and output impedance also increases. C option is input impedance decreases, output impedance also decreases, and D option is input impedance decreases and output impedance increases. And the network is shown over here. If you want to have a detailed concept regarding this problem, you can kindly refer the NPTEL lecture, that is Introduction to Feedback Amplifiers, and the NPTEL course name is Analog Electronic Circuits by Professor S.C. Datta Roy, Department of Electrical Engineering, IIT Delhi. The YouTube link is also shown over here. So if you want to solve this type of problem, let us have a quick concept regarding the feedback topology in the analog electronic circuits. So type of feedback, there are four possible combination for voltage and current with which we can sample at the output and mix the feedback to the input. Sampling, what will be my sampling? So we sample at the output and mix the feedback at the input. So we do sampling at the output and we are mixing the feedback to the input. For sampling at the output side, we will take a sample of output. Since we want to check the behavior of output, we don't want to disturb the output when we take the sample. So that's why when the voltage sample, it is in parallel as the voltage is the same in parallel. And current should be in series as the current is same in series, because we don't want to disturb the output when we are taking the sample. So when voltage gets sampled, it is in parallel, and when the current is sampled, it is in series. Now for mixing, in mixing end we want to affect the signal that is provided to the amplifier, since that is actual fundamental of giving the feedback. So the voltage will be in series and current will be in parallel, so that we can change the input and affect the change in output. So for mixing, voltage will be in series and current will be in parallel, so that we can so that we can affect the signal that is provided to the amplifier. So for sampling, we don't want to affect the signal. Therefore, for sampling, voltage should be in parallel while current should be in series, because we are taking sample but we don't want to affect the signal. But however, in mixing, we want to affect the signal that is provided to the amplifier. Therefore, for mixing, voltage will be connected in series while current will be in parallel, so that we can affect the signal that is provided to the amplifier. So upon this thing, we are having four basic topology upon the series and shunt connection, that is parallel connection. when we are doing the voltage mixing, so if you see voltage mixing means it should be series and voltage sampling. So series shunt topology that is called voltage amplifier. And the second topology is that current mixing, current sampling. Current mixing means should be in parallel, and current sampling that means it is in series. So shunt series topology. Voltage mixing, current sampling that is series, and current mixing, voltage sampling that means shunt topology. And the other name for this topology are shown over here. Like series shunt topology, we called it as voltage amplifier. Shunt series topology, we called it as current amplifier. Voltage series topology, we called it as transconductance amplifier. And for shunt topology, we called it as trans resistance amplifier. Now here we can see that at the output we are sampling the voltage, and at the input voltage mixing. So it is series shunt topology. Series shunt topology. And that this is also called as voltage amplifier. In similar way, this will be shunt series topology. Shunt series topology. This is called as current amplifier. This is called as current amplifier because both sides we are playing with current. We are doing the current sampling and current mixing. Current sampling at the output and current mixing at the input. And this is shunt topology. And at the output we are doing the sampling of current. At the input we are doing mixing of voltage. That's why it is called as transconductance amplifier, because at the output there is current and at the input we have voltage. Therefore it is transconductance amplifier. Sorry, this is series topology. This is not shunt. This is series topology, and this is shunt topology. Because both side we are having shunt connection at the output and input also, we are sampling the voltage at the output and we are mixing the current at the input. Therefore it is trans resistance amplifier. So one thing I want to mention here, if you are doing the voltage sampling, then this output resistance will gets reduced. ROF is equal to R naught plus 1 plus A beta. And if you are doing voltage mixing, then input resistance will get increased. That means RIF equal to Ri into 1 plus A beta. Here similarly we can write, here we are having the current sampling, that means this output resistance will get increased, and here this input resistance will get reduced, because at the input side we are having current mixing. Similarly here we can write RIF input resistance will get increased, and here output resistance will get increased. Ri 1 plus A beta. Similarly for last case, input resistance will get reduced, and output resistance will also gets reduced. So therefore I have make one table for all the amplifier topology. What will be the effect on the input resistance and output resistance? For voltage amplifier, as we have seen, the input resistance increases and output resistance decreases. And for the current amplifier, input resistance decreases and the output resistance increases. And for the transconductance amplifier, both the input resistance and output resistance increases. And for the trans resistance amplifier, both the input and output resistance decreases. Now let us come to the, so this is the summary for the amplifier characteristics. Now based on this summary, we will solve the problem. So let us come back to the problem. So here we can see that voltage is sampled at the output. Voltage sampling that is done in shunt connection. And here at the input, voltage is mixing. That is done in series connection. So this amplifier is of series shunt topology. Series shunt topology. And this is also called as, since at the output we are having voltage sampled and at the input we are having voltage mixing, so it is called as voltage amplifier. So at the output, this output resistance will be R naught divided by 1 plus A beta. That is output resistance is going to decrease. And at the input, this is going to increase. So this is the input resistance and this is output resistance. And here in this problem, they have told that feedback factor K is increased. So in the place of beta, we will use the K. So the meaning is same as it is. So then what should be the effect? So as we can see from the from the expression that this input and output resistance, if feedback factor K, that means beta, is increased, the input impedance increases and the output impedance decreases. Therefore, A is the correct answer. That's all. Thank you.